All right, so we are taking a look at 7.3 today. We're looking at confidence intervals, but this time though, and this is a new parameter for us, or statistic, actually looking specifically at a proportion for a population. I know it's something we haven't really ever looked at before. We've looked at the mean, variance, and standard deviation, but we've never focused specifically on proportions before. Just a refresher on proportion. I would not write these things. This is just a refresher for you. Proportion represents part of a whole. We can express proportions, fractions, decimals, or percents. Proportions can represent probabilities. And we can obtain proportions from samples or populations. So that's just a little refresher on proportions for us. The symbols piece, I wanted to make sure we spent a little specific time on the symbols before we jumped into the formula piece with this. There are a few new symbols for us. Just a little lowercase p is the population proportion. The p with what looks like a little arrow over it, it's actually said p hat. So it's actually said p hat. It looks like fat, yes. For a sample proportion, you have p hat, and then this one is q hat. To find p hat and q hat, we found those types of proportions before. We're probably a little more used to looking at them more as when we found probabilities. Your capital X is the number of items in your sample that have whatever characteristic we're interested in. And then the n in the denominator is your sample size. So it's just like when we found our classical and empirical probabilities. How many successes did we have? So how many items have the characteristic we're interested in out of the total number of items? That's what we're looking at there. Some of the assumptions for our confidence intervals. Assumption 1, we've had this assumption for every other interval we've created. The sample is a random sample. And then for number 2, I would just write the conditions for the binomial experiment must be met. I wouldn't take the time to rewrite those. We've written those a couple times. We saw our binomial experiments in chapter 5. So we've refreshed on those a couple times in chapter 5. We saw it again in chapter 6 also. So just go ahead and write down the conditions for the binomial experiment must be met. And then if you do need to refer back, they would be in your chapter 6 notes, chapter 5 notes, and they're also in your book too. So remember, for the binomial experiment, we have a fixed number of trials. The outcome of each trial is independent. So one trial happening does not affect the next one or the one after that or the one after that. Each experiment has only 2 outcomes, or your outcomes can be reduced down to 2. And the probability of success is the same for each trial. So again, we get to assume those things. Sometimes we're told them in the particular problem situation, but other times we're not. We get to make that assumption. Okay, we, unfortunately, for this course, we're not the researcher, we're not collecting the data, we're not ensuring that these things happen. These are things that we are assuming happen. So the actual formula piece, I know we already talked about a lot of the variables, but the actual formula for our proportion, we have our p hat. You see p hat and q hat. we have a z sub alpha over 2. We're familiar with that from our confidence interval for the mean already. Then you have little lowercase n as your sample size. One of the conditions that must be met, and it's one that we will check, if you take your sample size times p hat and your sample size times q hat, both of those need to be greater than or equal to 5 for you to be able to use this confidence interval. The margin of error piece, remember that is just, and you can see it in the formula itself, the margin of error is just how far away we are either above or below that population proportion. So how far above and below could we actually go, not population proportion, that sample proportion. How much are we going to take away from the sample proportion? How much are we going to add on to it? And then this rounding rule, I know I've really been stressing the rounding rules this chapter. For your proportions though, we want to make sure if we need to round, if you can leave them as fractions, great, but round off to 3 decimal places. Sometimes when we're dealing with proportions, the decimals can get kind of small. So sometimes if you just follow our other rounding rules and we round off to the nearest 10th or nearest 100th, sometimes we just end up with zeros there. And 0 is not going to be super helpful in our interval. All right, so we are going to try a sample problem. We're going to look at page 396, number 8. So if I know you guys are mostly doubled up there, if one of you just wants to open your book to that page, that would be fantastic. All right, in question 8, we have a CBS New York Times poll found that 329 out of 763 randomly selected adults said they would travel to outer space in their lifetime, given the chance. Estimate the true proportion of adults who would like to travel to outer space with 92% confidence. So some of the pieces we need to find before we can even worry about plugging and chugging in the formula. We have to first of all find p hat. We need q hat. We need z sub alpha over 2. And we need our sample size. So those are all the different pieces we need. P hat and Q hat, remember, those are our sample proportions. So we're looking at the true proportion who would like to travel to outer space. The 329 people that were selected said they would like to travel to outer space. So we have to make sure that the proportion that P hat represents is the same characteristic we want our confidence interval to represent. So our confidence interval, we want that they would like to travel to outer space. So we need to make sure P hat matches that they like to travel to outer space. We could have been given information that they like to travel, but then maybe the interval could represent that they don't like to travel. So you have to be careful when you're deciding on P hat and Q hat. So we would like to travel to outer space was 329 out of 763. If you can, simplify the fraction if you can. Remember, all of your graphing calculators will do that. If you enter in 329 divided by 763, you'll get a decimal. Then you can press math and just hit number 1 for fraction. We get 47 out of 109. Leave it as a fraction unless the decimal is terminating, unless that decimal works out really, really nice. keep the fraction. We don't want to round till the very end. We want to keep this as accurate as possible. All right, so if p hat is 47 out of 109, to get q hat, we just need to do 1 minus p hat. Excuse me. So we would have 62 out of 109. Remember, p hat plus q hat should equal 1. The conditions for the binomial experiment must be met, so we only have 2 possibilities. Either they like going to outer space or they don't. So p hat and q hat need to give us a total of 1 when we add them together. Now the z sub alpha over 2, I want to make sure I go through this piece with you. I will show you table E again, and I will also show you the calculator, how to find that z sub alpha over 2. I know for some of you, you're just using the calculator shortcuts for the intervals, but when we do sample size, you can't shortcut it. You have to be able to find z sub alpha over 2. All right, so in order to do that, we have a 92% confidence level is what we're looking at. So to get alpha, we have 1 minus our 92. And then we need alpha divided by 2. However much of this you need to show, some of you I know are already super comfortable with this. The idea with dividing alpha by 2, our 92%, or our 0.92, is in that middle section. The alpha piece is the leftover area that's not shaded, the area we're not interested in. That's the alpha piece. So to split it amongst the 2 tails, we divide alpha by 2. Our goal is we're trying to find the z value that will keep that area to the left. The z values that will keep that 92% in between them. So you have a couple options. You have a couple options. I want to make sure I show these. So I'm going to bring the table up. I know I still have some people liking to use the table. We're on the left side of the distribution. The table always gives you the area to the left, so find the z value on the left. It's going to make life a little simpler. All right, so if you're a table person, you need to find in the table the area as close as you can to your alpha divided by 2. Now we're talking about in the body. Whoa, sorry guys. We're talking about in the body of the table. So the body piece. And then we have to work backwards to get the z value. So as close as we can, 0.04. Looks like right here is our winner. We have negative 1.75. Negative 1.75. Now we have to keep in mind, if this right here is negative 1.75, what's the positive one? It's also 1.75. So my z sub alpha over 2, whenever we record it, we want to keep it as the positive one. When we put it in the formula, that's when we worry about we're going to subtract it and we're going to add it. Keep it the positive one. Calculator-wise, I know some of you, more of you have been converting to the calculator. So let's check that out. To find that area using the calculator, to find z sub alpha over 2, we go second, distribute, so second vars. If we did normal CDF, we would input z values and get an area out. If we do option 3, that's when we have an area and we go in reverse and we get the z values. But the area we enter in needs to be that alpha divided by 2. It needs to be the area to the left of the z value we're trying to find. Now I know for some of you, you have the options like I have on my screen up here, whoops. Some of you have the options that I have on my screen up here. You can, if you have the options, if you have a 92% confidence interval, you can just put the 92% in there. I don't know why that keeps switching on me. Sorry, guys. I keep accidentally hitting VARs. You can highlight center. If you have one of these super new calculators that gives you the option of left, right, center, you can tell the calculator where the area is you want it to find. If you don't have those options, there's nothing wrong with your calculator. It's just not super new. You have to keep yours on the left, and you have to enter an alpha divided by 2. You have to enter an alpha divided by 2. And we get, there's our negative 1.75. Remember, please round your z-values to the nearest hundredth, so then all of us will match up. You don't have to worry about, oh, Miss Golly, my answer is a little off from yours, or it's a little off from the answer in the book. Round to the nearest hundredth. So you have your option, table E or the calculator. Either one of them gave us the same result for our alpha divided by 2. We get 1.75. The last piece we need is our sample size. Our sample size is how many items were in our sample. In this case, 763 people. So we have all the pieces that we need. So now let's go to the formula. In the formula, we start with p hat, and go ahead and use the simplified, the 47 out of 109. You don't have to simplify it, but I always think it makes it a little easier. Minus our z sub alpha over 2. And then there's a giant square root there. In the numerator is q hat times p hat. And then the denominator we divide by our n, which is our sample size. The symbol in the middle of the interval, keep in mind I will be picky come test time how you write your final answer. You have to write it as an interval, and you need to have the correct symbol in there. So for a population proportion, we talked about symbols earlier, population proportion is just little p, it's just lowercase p. The right side of your interval, it's kind of the nice thing about these intervals, it's the same thing on both sides except we add that margin of error. We add that z sub alpha over 2 times the stuff in the radical. Now I know some of you have started using some of the calculator programs and shortcuts. There are calculator steps available for this. They are on page 397, so the page that's right next to the one we're doing this problem from. So if you're interested in that. Otherwise, if you've been kind of steering clear of the calculator programs, take a minute and try to do the computation for this, entering in that giant square root and things like that. Again, if you want to try out the calculator stuff, they're right on the page next to this on page 397. Otherwise,
why is it 765?
Oh, 763. Sorry. There we go. Sorry, guys, my end was wrong. 763. There we go. Now, if you're rounding this, we set it around to 3 decimal places. This originally is 0.3998116, etc. So if I'm going to round to 3 decimal places, that 9 bumps up, then the next 9 bumps up, and then the 3 is going to bump up. So if you round this to 3 decimal places, it actually becomes 0.4 and then 2 zeros. The 2 zeros, yes, you need to have them there because you have rounded to the nearest thousandth. So we need to show that. We didn't round to the nearest tenths. So 4/10 doesn't cut it. We need those extra zeros behind it to show that's what we rounded to. On the right-hand side, the rounding's a little more straightforward. Should get 0.463. Just to show you, I know for some of you, if I don't show the calculator steps, you just kind of don't bother with them. I will show you the steps for this one, just to show you that the technology can make life a little easier. It can. But the only catch is you have to know, you have to make sure you do the practice so you know where to find the particular things you need. Because remember, on test day, I'm no longer helpful with the calculator once you start your test. So if you make the choice to use the calculator programs, you have to commit to it and you have to practice it. So I just want to give you an idea before we do our final little piece here. I just want to give you an idea of how the calculator can simplify things for you. For this particular problem, we go to Stat, and we arrow to Tests. This is where you find the ones for our other intervals as well, except for chi-square. Remember, there are no chi-square shortcuts in the calculator. So what we want, and again, this is part of having to know what you're finding. This is a 1 proportion z interval. 1 proportion z interval, and the calculator steps are in your book. They're on page 397. Step 1, it says press stat, move cursor to tests. Then it says to press capital A, and that's the one we need here. The x value you're entering in, that's how many items from your sample have the characteristic that we want. That's the numerator from p hat, and that was 329. Your n is your sample size. Let's make sure I get it right this time, 763. Confidence level, your C level is your confidence level, and we had 92%. You just have to make sure you enter that as a decimal. You press calculate. There's your interval. And it even gives you p hat also if you need that for any additional things. But there's your interval. Now, it doesn't write it as an interval for you, so again, I will be very picky come test time that you write your interval with the inequality symbols and with the correct symbol in the middle of it. So this will give you the minimum and maximums, but you still have to take the time and know how to write it as the interval. The ones for the mean, the 2 mean ones we did with z and t, those are also in there too, and the calculator steps are right at the end of those sections in the book. If you are interested, after you see this one, go back and take a look. But again, you have to know where to find these, how to use them, and how to write your interval from these. So they still do take some practice. It just shortcuts the busy work of the formula. You still have to know when to use this one. You still have to know how to use it. You still have to be able to interpret the answer. It just shortcuts the busy work of the formula for you. That's all it does. All right, our last piece we're going to look at, and there's not a shortcut for this. This is similar to when we found the confidence interval for our mean, when we knew the population standard deviation, so our very first section. Sometimes as a researcher, you have a specific margin of error in mind. I think the sample problem we did in section 7.1, there was a person that owned a pizza place, and they wanted to find the average price of a large pizza, but they wanted to be within 15 cents. So they needed to figure out what the smallest sample size was they needed to be within 15 cents of the mean. So same idea holds here. They might have a specific proportion in mind, what their margin of error, what they want their margin of error to be, and so they have to ensure that they have that minimum sample size needed to stay within the margin of error that they want. The part of this that I want to make sure I highlight for you is again that idea that we have to round up to obtain a whole number. I know some of you are asking me questions about that in 7-1. Even if you get something like 4.01, you still have to round it up to 5. So the typical rounding rules, we're not rounding off, we're rounding up. No matter how close we are to that lower whole number, we still have to go up. We need to ensure that we have the minimum sample size. It still has to be big enough. So the only way to ensure it's big enough is we have to round up. So let's just try one of these out to finish up today. Sticking with the same page, we're going to look at question 16. And there is an A and B. I do want to do both of those with you. We have a recent study indicate that 29% of the 100 women over age 55 in the study were widows. Letter A wants to know, how large a sample must you take to be 90% confident that the estimate is within 0.05 or 0.05 of the true proportion of women over age 55 who are widows. So again, how do I know this is what I need to do? You're asked, how large of a sample must you take? You're specifically being asked for sample size. And then how do I know to use this one versus the one we did in section 7-1 for the mean? We're being asked for a proportion, not a mean. So you will be asked how large of a sample is needed, and you will be told what you're looking for, if you're looking for a mean or a proportion. So into our formula, a few pieces that we need. We need P hat, we need Q hat, we need Z sub alpha over 2, and we need our capital E. Again, when you are selecting what your P hat should be, you have to make sure that P hat matches up with what the interval is trying to show. So this interval is going to show the true proportion of the women who are widows. The 29% matches with that. The 29% have that same characteristic. So for our proportion, we can just write the 29%, just write it as a decimal. You don't have to do 29 over 100. If you have a nice decimal, use it. It makes the formula a lot easier to use. All right, and then Q hat would then be our 71. Remember, P hat and Q hat have to add together to equal 1. Now, the only catch is the calculator stuff I just showed you. If we were actually trying to find the confidence interval for this, if you were going to use the calculator to find a confidence interval for the proportion, you would have to change those percents into fractions. Because to use the calculator, you need X and you need N. So putting in a decimal wouldn't work if we were trying to find the confidence interval for the proportion. So just be careful of that. There's no calculator shortcut for this, but if we were using it on the last one, you have to have a fraction to do that shortcut. Z sub alpha over 2. Again, there's no calculator shortcut for these, so you have to be able to find Z sub alpha over 2. Whether it's table E, like I reviewed earlier, or the calculator steps, it's up to you. The confidence level we're working with is 90%. Confidence interval is 90%. Now for this one, we've talked about this one earlier. If you're using the table in the book, you end up with 1.65. If you use the calculator, you end up with 1.64. I don't care which one you use. Just when you take your test, write down what z sub alpha over 2 you used. You're going to want to show your work as much as you can, as always. So make sure you tell me what your z sub alpha over 2 was. And I'll see it in your formula too. There's no shortcut for this. You have to use this formula. The E is our margin of error. So how close do we want to be? And we want to be within our 500. So our 0.05 is what we want to be within. So our sample size, we start off with p hat times q hat, p hat times q hat. I like to just use parentheses for that multiplication. Z sub alpha over 2. I'm going to go ahead, I'm going to use, I know most of you are using the calculator, so I'm going to go 1.64. 0.05 is our margin of error, it's our capital E. And then same with our other sample size formula for our mean. The most forgotten thing is that little squared right there. That's the most forgotten thing. For your calculator, you can enter this in right as you see it. You don't have to worry about any extra sets of parentheses, as we sometimes have to. Don't forget to square that last piece. So this is roughly 221.515-ish. You have to round up. So 222 would be the sample size we need. We would need 222 to be our sample size. Always round up. Now, if you used 1.65, if you're a table person and you had 1.65 that you chose to use, that's okay. Just going to do the math real quick for that. If you use z sub alpha over 2 as 1.65, your n comes out to be about 224.22-ish. You would have to still round up to 225. And I'm okay with that difference in there. Some of you are more comfortable at the table, and that's fine. I'm not going to penalize you for that. Some of you are like, hey, calculator short and sweet. I'm going to do that route. Either value is okay. Just be aware, though, your textbook will typically use the same value from the table. Sometimes it will add in there that if you use the calculator, it gives the other value. Sometimes it doesn't. So just to be aware, the textbook will use the 1.65 because that's what would come from the table if you did this. So just to give you the heads up there on that piece. Part B on this. Part B says if no estimate of the sample proportion is available, how large should the sample be? So sometimes as a researcher, you're working from scratch. You don't have another sample to get a p hat and q hat from. So you want to make sure that your sample size is large enough. So you want p hat times q hat to be as big as it possibly can be. What I have up on the screen here, don't worry about copying all those down. I know they're kind of small to see, I apologize. I want to find where the product of p hat and q hat is going to be at its largest. So what I have up here are the possible pairings for p hat and q hat. And if there's anything in between there, it's not going to matter. So I'm trying to find where the product's going to be the biggest. So the product is largest when p hat and q hat are each a half. So if there's no sample proportion available to you, if you cannot find a p hat, if p hat is not given to you, you make p hat a half, which also in turn makes q hat a half. The idea is we need a minimum sample size. We have to make sure that the sample is big enough to get the margin of error that you want. So to make sure it's big enough, we want that product that's in our formula to be at its biggest also. So if we go into the formula, we would have n equals p hat would be a half, q hat is a half, and then our other pieces are still the same. Our z sub alpha over 2 and our margin of error, don't forget to square it. So we have a half times a half, and then we have 268.96. So we have to round up to 269. So again, the idea with this piece, we don't know p hat. We don't have a prior sample or a prior study to get p hat from. We don't have that. If that happens, we want to make sure that this part of the formula is at its biggest, to make sure that as a researcher you get a big enough sample size to keep that margin of error where you want it. So p hat and q hat, that product's at its biggest when those are each 1/2. The assignment piece for this, we already did 7-4. There we go. The assignment piece for this, you see it there. Not a ton of problems. Again, the technology piece, when I put technology, that's the calculator stuff. And we already did that piece, but if you need to refer back to it, it's on page 397. There's not a calculator shortcut, though, for the sample size formula. There are calculator shortcuts, though, for our 2 confidence intervals that involve the mean. If you want to go back to those sections and refer to those, you can. Now, if you think, oh, those calculator steps look pretty easy, they are pretty easy. So if you want to try them out, you can. Let me know what I can help you with.